Now we're looking at the Math 136 test review for probability. Now this should cover majority, if not all, of the topics from this unit. Alright, so let's get started here. Number 1. In a math class, 23 students own an iPod and 9 do not. So the first thing you would really want to do here probably is add those numbers up and figure, alright, there's 32 students. Right? So you would probably do 23 plus 9 and get 32. That's how many students there are altogether. So what's the probability that a student owns an iPod? Well, 23 own the iPod out of 32 students altogether, right? Because again, this is just the number of favorable outcomes over the number of total outcomes, right? So there's 23 favorable outcomes because 23 students own the iPod. There's 32 total outcomes because there's 32 students total in the class. Alright, and then B, what's the probability that a student in this class does not own an iPod? Well, right here it says 9 do not own the iPod, so this would just be 9 out of 32. Right? And of course those two values, 23 out of 32 and 9 out of 32, have to add up to 1 because they're complements of each other, right? 1 is not the other one, right? So A was the probability that a student owns an iPod, B was the probability that the student does not own the iPod. So when you add those two probabilities up, they must add up to 1, which they do. Alright, now 2, you ask someone to randomly select an integer from 1 to 10. Okay, so there's 10 choices there. What is the probability that an even number is selected? Right, so that's again, that's the first thing to note here. There's 10 choices, so there's 10 outcomes. Alright, so what's the probability that an even number is selected? So what are the even numbers between 1 and 10, including 1 and 10? Well, you could have 2, 4, 6, 8, or 10. So there's 5 outcomes that are even numbers out of 10 outcomes altogether. So 5 out of 10, or you could reduce it to 1/2. Alright, now B, what's the probability that a multiple of 3 is selected? So what are the multiples of 3 from 1 to 10? Well, the multiples of 3 are just the 3 times tables, right? So 3, 6, 9. Now the next one would be 12, but 12 is greater than 10, so it's not going to work. So there's only 3 favorable outcomes out of 10 possible outcomes, so 3/10. And then C, what's the probability that an even number and a multiple of 3 is selected? So what you would do here is you would find the ones that are common to both my lists up here, right? I have 2, 4, 6, 8, 10, and I have 3, 6, 9. So the only ones that are actually common to both, well, there's only one, right? Not ones, there's only one that's common to both. And that would be 6, so it's actually 1/10, right? Now I could see people seeing this word "and" here and thinking that it's one of those multiplication problems, but no. Those multiplication problems occur when there's multiple steps. So like if you were selecting, 2 numbers here, then you might have a multiplication problem. But here you're just selecting a single number. So all you were doing is you were finding the number of outcomes that were both even and multiples of 3. So there's only one of them. So the probability was 1/10. So you got to be careful with that one. And then D, what is the probability that an even or odd number is selected? Well, the even numbers are 2, 4, 6, 8, 10. The odd numbers would be 1, 3, 5, 7, and 9. And if you take all those together, that covers all of them. So it's actually 10 out of 10. And when a probability is like that, you would just write it as 1, because that means it's a certain event. It's definitely going to happen. You have to get an even or an odd number. You have to get an even or an odd number. Right? It has to be one or the other. And 3 is more of this basic probability here. So there's 60 people in an Italian restaurant, 43 people ordered a salad. So what's the probability that someone did order the salad? See, now this is a little different because in this case 60 is the total. So that's going to be your denominator. And they're telling you that 43 people out of the 60 ordered a salad. So what's the probability that someone ordered a salad? 43 out of 60. Okay? And then B, the idea now here is, what's the probability that they did not order a salad? This is just that rule. So the probability of not, I'll actually write it out. The probability of not salad is going to be 1 minus the probability of salad. So in this case it's 1 minus the answer to A, which was 43 out of 60. But I mean, this one, could you do this without the formula? Of course. Because I mean, just think about it. If 43 people ordered the salad and there were 60 people total, how many didn't order the salad? Well, it's just 60 minus 43, which would be 17. So the probability that they didn't order the salad was 17 out of 60. Alright, now 4 and 5 get into this idea of expected value and fair price. Okay, so 4 is a raffle. You buy one raffle ticket at the county fair that costs $2, and the raffle is limited to 2,500 entries. The grand prize is $2,000, and there are 10 consolation prizes of $200. So this is a nice problem because it takes you through it in steps, so we don't have to worry about the expected value formula until later, until part D. So before we even get into expected value, just think about this. So what's the probability of winning the grand prize? Well, there's one grand prize out of 2,500 entries. So the probability of winning the grand prize is going to be 1 out of 2,500. And now with the consolation prize, there's actually 10 consolation prizes, not just one. So there's 10 winning entries for the consolation prize out of 2,500 total entries. So there's a greater probability of winning the consolation prize because there's 10 consolation prizes. Okay, so that's B. And then what's the probability of winning nothing? Well, there's only 3 options here. You're either winning the grand prize, you're winning a consolation prize, or you're winning nothing. So really what it is it's just 1 minus the probabilities of the grand prize or the consolation prize. So if there's 11 total winning entries out of the 2,500, that means there's actually, the way to do it is just say 2,500 minus 11 out of 2,500. So if you take away 11 from 2,500, you end up with 2,489 out of 2,500. So that's a big probability, right? There's a big probability that you're going to win nothing. All right, so what is your expectation? Now this is where you get into the expected value formula, okay? So in this case, there's really 3 events. So you're going to have P1A1 if you win the grand prize. We'll call that the event of winning the grand prize. Plus P2A2, which is going to be winning the consolation prize. Plus P3A3, which is going to be winning nothing. Now here's a thing to consider. So let's label this. This would be for the grand prize. This would be for the consolation prize, and this is for nothing. Alright, so now we got to label these things. The P's we already have, right? We have the 3 probabilities. The probability of winning the grand prize is 1 out of 2,500. Probability of winning the consolation prize is 10 out of 2,500. The probability of winning nothing is 2,489 out of 2,500. Now the A's are what we don't have. So if you win the grand prize, which would be A1, right? How much are you winning? Well, you're getting $2,000, but you paid $2 to enter. So you're really only winning $19.98, and that's the thing you just got to make sure you do. You just got to subtract the cost that it was to play from the prize. So it was $2,000 minus $2, which was $19.98. And then the same thing you do with the consolation prize. If you win the consolation prize, you get $200, but you paid $2 to enter, so you really only get $198. And then, of course, A3, if you win nothing, well, you didn't really win nothing, you actually lost. You lost your entry fee, which was $2. So since you lost it, it's negative 2. All right. So now I have everything I need to find my expected value. All right. So I would just multiply P1, which is 1 out of 2,500, times the amount that I win if I win the grand prize, which we said was $19.98, plus the probability that I win the consolation prize, which was 10 out of 2,500, times the amount I win if I win that, which is $198, and then I add that to the probability of winning nothing, which was $24.89 out of 2,500, but I would actually multiply that by the $2 that I would lose, negative 2, right, if I don't win anything. So my expected value here is just, really what it's going to be is it's just going to be something over 2,500. You can do this on the calculator, of course, but this would be 1998 plus 1980 minus 2489 times 2 is going to be minus 49.78. Alright, so my expected value would actually be this. Now I'll do it on the calculator. Right? I would have 1998 plus 1980 minus 49.78, negative 1,000. So this is going to be negative 1,000 of 25 over 2,500, which is really negative 2/5, which is really negative 0.40, or negative 40 cents. So what does your expected value mean? It means that you wouldn't expect to win, right? You expect to lose if you entered this raffle, right? Chances are you're going to lose. Now, can you possibly lose 40 cents? No, of course not. Because if you're paying $2, we just said there's 3 possibilities. You're either winning the 1998, you're winning the 198, or you're losing the 2. So you can't lose possibly 40 cents. But that would be your expected value. You'd be expected to lose. And then 5 is just this idea of fair price. And there was a little formula for fair price, which said that fair price was expected value plus the cost to play. So in this case, the expected value was negative 4. The cost to play was 5, because that's what it cost. So negative 4 plus 5 is actually 1. So in this instance, the fair price would be $1. And again, remember, the fair price is the amount that would be charged if the house, the people that are running the raffle or game or whatever you want to call it, would break even.